So now we're going to look at our outliers, and I know I mentioned this earlier and about outliers, and so now we want to kind of formalize the definition and talk about how to detect some outliers here. So an outlier is just a value that's extremely large or small relative to the other values, right? And so when we talked about the histograms and there, or really the distribution of the data, right? We had points that are way out here, far away from the other point. And so those are potential outliers there. So it's just far away from the other values, and then maybe skewing, right, our data in there. And so when we look or find outliers, or what we call potential outliers, we need to see, why we've got a value that looks so out of place compared to the other values in the data set. So possible reasons for outliers are, it's, possible that there's a data entry error, right? Somebody, just hit a 2 instead of a 1 or something, right? So it's always possible that, there was an entry made or an error made when entering the values in there. Another one is that, the observation could be from a different population. So when we were sampling, individuals that, somehow we've got this other individual who's not part of the population that we are interested in looking at in there. And so that's always a possibility as well. And finally, it could just be a rare event in there. When we talk about, a rare event, if we're, looking at the heights of females, and maybe, we had somebody come by that was, 7 feet tall, 7 foot tall female. Again, that's extremely rare to see, a female that tall. It's possible, right? It's not impossible, but, it's just something that's rare that we don't see. And so that could be, this value out here at the upper end of the distribution in there. So it's plausible, but, just something extremely rare that can happen. And so a lot of times, right, when we look for outliers or see outliers in our data set, we always want to kind of check to see, what's the reason for that outlier, if we can identify it. There may be times where we don't know why that value is in there. And so if we, find an outlier, then we have to decide, do we keep it or do we discard it in there? If it's a data entry error, again, if we can go back to the original data, then find out what that value is supposed to be, then we can change it in there. If it's from a different population, then obviously we probably don't want to include that in our data set. And then the rare event case, that's the one where we kind of have to think, do we include it or not, because it's possible, but it's just extremely rare. Now, right? Okay, so to identify outliers, right, we have, analytical ways of doing it as well as graphical. And so we've talked about looking at histograms, right? And, using that to identify outliers, just some values that are far away from the others, right? And so analytically, what we do is we use the standard deviation here. And so for a reasonably shaped distribution, if a value is more than 3 standard deviations from a mean, then, that's a possible or potential outlier, or we say probable outlier in there. So we think of our distribution of our, data. And so here, when we start getting out here to the extremes, right, at the very ends of the distributions, right? So if they fall in this end or this end, here they're, potential outliers, right? We just need to look and see why we had those values there. And so, that's for reasonably shaped, and so usually symmetric, kind of bell-shaped distributions, usually what we're thinking of in this case here. But now if you got a skewed distribution, or really for any distribution, anything more than 2 standard deviations from the mean is a potential outlier in there. And so this is, definition we usually look at is 2 standard deviations in here. So just a normal, right, kind of standard distribution if I'm, here and here. So anything out, here, if this is 2 standard deviations, here's our mean, right? So this is a couple standard deviations below, a couple standard deviations above. So if we're below this point or above this point, then it's a potential outlier in there. If I've got something that's extremely skewed or really highly skewed, something like this, here. So our mean is going to be, about here, roughly. So, 2 standard deviations below is probably about here, 2 standard deviations above about here. So we get these possible values as our outliers up here. And so usually a good rule of thumb is, 2 standard deviations from the mean. If it's more than 3, then that's a highly likely to be an outlier in there, right? So just usually we use the 2 standard deviations rule of thumb in there. So that's one way, right, that we have for identifying potential outliers analytically. Another way we have is we use the interquartile range. And so remember the interquartile range, right, the IQR, the interquartile range, that was just what, Q3, right, minus Q1, right? The range of our middle 50% of the data in here. And so what we do here is if a value is what, greater than 1.5 times the IQR more than Q3, right? Or if it's smaller than what, Q1 minus 1.5 times the IQR, then again, it's possibly an outlier in there. And so this is another way, right, we have of looking at it. And then if we can extend that up to, 3 times the IQR above and below Q3 and Q1 respectively, then it's probably a highly probable outlier in there. And so this here, using the IQR, is another way we have of identifying possible outliers in there. So usually, this method here is pretty standard to use as well. But if we have a highly skewed distribution, then we can for sure use this IQR method here. But again, if we got something that's reasonable, we can use the mean and the standard deviation as well. We can usually look at the mean and standard deviation, or we can use the IQR. And we like to use the IQR because what we can do is we can use what we call a modified box plot here. And so the modified box plot, what it does, it takes into account this 1.5 IQR above and below Q1 and Q3, and it shows us, right, if we have outliers. And so again, just a quick review. Here, this is a standard box plot, right? It's our 5-number summary over here, right? Our minimum Q1, the median Q3, and the max. So here's our box plot. Again, here's our maximum value up here, the extreme end, the minimum down here, the extreme, the maximum up here, the upper end, right? So these are the, whiskers, or sometimes they'll call this a fence as well. Then the hinges, which are the edge of the box. Again, that's Q1 and Q3. And then, our median in the middle here. So again, if we look at this here, right, our box plot, then we know that, this distribution is actually skewed, right? If we look at it, because it's not a symmetric box plot here. So now here, there may be some outliers or potential outliers in here, right? And so what we do with the modified box plot, instead of the minimum or the maximum, here we're going to replace the minimum with what? Q1 minus 1.5 times the IQR, and we replace the maximum with Q3 plus 1.5 times the IQR. And so remember, the IQR, just Q3 minus Q1, so it's about 23.18 in this case here. And so if we add and subtract that, then what we get, the upper end about here, the lower end, so that's Q1, Q3. So these are Q1 minus 1.5, the IQR, Q3 plus 1.5 times the IQR here. And so we stop our fences here, and then any points above that, we just kind of put them on the graph so we can see if they're our potential outliers here. So what that looks like here is something like this in here. So here's our box plot. So now instead of the minimum and the maximum, we're replacing it with Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. And so any points below, in this case 55.4 or 148, or above 148, here, these are potential outliers in the data set. So we'd need to look at these values specifically to see what the reason is for these. That are naturally occurring, possibly just a rare event, or maybe there was a data entry error in there, like this one here. Maybe instead of 238, that was supposed to be 138. So that should actually be back down here someplace. So always go back and look to see, what the reasoning is for these potential values in here. right? And then, if we do have, outliers in there, then we have to determine, whether we want to use or not use these, right? If we can't find the reasoning for them, or if we can't make the correction, if it's a data entry error in there, then we have to decide whether we want to, include it or exclude it in there. And so again, if it's the rare occurrence, then what we do is we run the analysis with and without it to see how it affects the values, especially the mean and the standard deviation, right? Do we see a substantial change in the mean when we exclude, right, that value? And do we see, big change in the standard deviation also if we exclude that value in there? And so, run it with and without, and then decide, well, do we keep it in or not? Usually if we've got a small data set, right, we don't want to lose points, so we want to do whatever we can, right, to see if we can include that value in the data set. If it's a large data set, then usually removing that point's not going to have as much of an effect on the analysis in there. And so again, whenever we look at data, right, it's always important to check for outliers here, right? So always remember, check for outliers. The easiest way to do that, again, is to usually just do this modified box plot, or you can do a histogram as well to kind of check to see for outliers.